Ever wondered why mirrors flip left and right, but not up and down? It seems so simple, but the truth is way more mind-bending than you'd expect. In this video, we're breaking down the science and psychology behind mirror reflections, and why your brain is playing tricks on you. It's not what the mirror is doing, it's how you're interpreting it. Stick around to have your perception flipped inside out. This illusion will make you question everything you thought you knew about reflections. When people look into a mirror, they often say that it flips the image horizontally. Your left becomes right and your right becomes left. At first glance, this seems intuitively correct. You raise your left hand, and the person in the mirror appears to raise their right. But in truth, mirrors don't actually flip images horizontally or vertically. Instead, they reverse them along the front-back axis, the direction extending directly from your body to the mirror. This is called depth reversal. The perception of a left-right flip is not due to what the mirror is doing, but rather how our brains interpret and expect reflections to behave. It is a deeply human phenomenon tied to how we interact with others and our own bodies. To understand what a mirror really does, consider what happens to a single point of light. When you shine a flashlight straight at a mirror, the light bounces back along the same path. Every ray of light coming from your body travels to the mirror and is reflected back with the same angle relative to the surface. So if a point on your nose sends light forward, it reflects directly back to your eyes. If your left eye sends light forward, it bounces back along that same line. The mirror doesn't switch sides, it just returns the light. As a result, all the positions of your body parts are preserved with respect to the vertical and horizontal dimensions. Your head is still at the top, and your feet are still at the bottom. Your left is still on your left, and your right is still on your right. What changes is the orientation along the axis going into the mirror, the depth. The reason this is confusing is because we humans are used to interacting with other people, and when we face someone, we don't just stand still, we rotate. For example, if you stand in front of a friend and raise your right hand, your friend sees your right hand on the left side of their field of vision. This is because you have rotated your body around a vertical axis to face them. The mirror, on the other hand, does not rotate to face you. It simply reflects. The image you see in the mirror is not a person who has turned to face you. It is you, reversed in depth. Your mirror self has not rotated. Instead, it is as if your entire body has been pushed backward into the mirror, keeping all its parts where they are but flipping the forward-backward orientation. Because we're so used to interacting with rotated humans, our brains instinctively interpret the mirror image as another person turning to face us. And that's where the idea of left-right flipping comes in. Our minds imagine the mirror image as a version of ourselves who has turned around, just as a friend would. But if you imagine a person turning around to face you, then their left hand ends up on your right, and vice versa. The mirror isn't doing this. It's your own mind supplying the rotation and interpreting the reversed depth as a horizontal flip. This leads to a strange conclusion. The mirror doesn't flip left and right, and it doesn't flip up and down either. It flips front and back, yet our brains interpret this as a left-right reversal, because we associate facing someone else with a horizontal transformation. That's also why mirrors don't appear to flip vertically. You can do a handstand in front of a mirror, and your reflection will still have its feet at the top and its head at the bottom. This seems completely normal, because we do not normally interact with upside-down people. If you were to interact with someone who flipped head over heels to face you, then perhaps vertical flipping would feel more intuitive. But since that's not how we're wired to interact, we don't interpret the mirror that way. Another way to look at this is to imagine text written on a shirt. If you print the word hello on your shirt and stand in front of a mirror, the text appears backward. This seems to support the idea of a horizontal flip. But what's really happening is that the mirror is showing exactly what someone would see if they stood behind you and looked through your body. The text appears reversed because you're used to reading it from the front. The mirror shows what's on the front of your body, but reversed in depth, not rotated. That's why hello appears as ole. Each letter has its depth reversed, not its lateral orientation. It helps to think in terms of coordinate systems. In 3 dimensions, we have an x-axis, left-right, a y-axis, up-down, and a z-axis, forward-back. A mirror reflects along the z-axis. That is, it reverses depth. If you were to raise your right hand, which is on the positive x-axis side of your body, your reflection also has that hand on its positive x-axis side. The mirror does not change the x or y coordinates of your body. It only changes the z coordinate. Everything gets pushed back. So the left and right stay the same, but the orientation feels flipped because of that reversed depth. This might be easier to grasp with physical objects. Imagine placing a glove on a table and then putting a mirror in front of it. The mirror image shows a glove that is identical in shape and size, but if you were to try to wear the mirror version of that glove, you'd find that it doesn't fit your other hand. That's because a real glove for your right hand is not simply a reversed left glove. It's a 3-dimensional object that's asymmetrical. Reversing it in depth does not make it into a glove for the opposite hand. Again, the mirror hasn't flipped it sideways. It has turned it inside out in a way, by reversing the depth. Ultimately, the confusion about mirrors comes down to how we perceive space and ourselves in it. We're used to certain kinds of symmetry, especially left-right symmetry, because that's how our bodies are built and how we relate to others. When we look into a mirror, we unconsciously try to interpret the image in terms of human interaction and bodily symmetry, not in terms of optical physics. The mirror image is not of someone who has turned around to face us, but of someone who has been reversed in depth. This subtle distinction makes a huge difference in how we experience our own reflections. It's not the mirror that flips us, it's our perception that does. Thanks for watching. If this flipped your perspective, like and subscribe for more mind-blowing explanations. Drop a comment with your thoughts or questions. Let's keep unraveling these everyday mysteries together.